All right, so in chapter 5.1, graphs of reciprocal functions, we learned two things. We learned how to do the reciprocals for linear functions, which are slightly easier, and then we learn how to do it for quadratic functions. Let's start with linear functions. So let's say I have a function f of x equals to 3x minus 5. When I look at this function, I should be able to tell my x and y intercept immediately. In this case, if I sub my x as my 0, if I look at this number, I know that my y-intercept is -5. And if I sub in my y as 0 and I solve for my x, so I'll show that really quick over here, but you should be able to do this in your head. I get my x-intercept as 5/3. But again, should be able to tell it instantly. You do not want to be solving this in a grade 12 class. Now, let me sketch this out really quick. My y-intercept is -5, and my x-intercept is 5/3. So this is what my linear function looks like, and technically you should be able to draw this very quickly, no problem. Now, if I'm doing my reciprocal function, we know that our vertical asymptotes of our reciprocal function is the same as the zeros of our original function. So my reciprocal function is going to be 1/3x minus 5. It's basically what reciprocal means, 1 over that function. Over here, my vertical asymptote is the same as my x-intercept. It's going to be x equals 5/3. So x-intercepts turn into vertical asymptotes. My horizontal asymptote is always going to be y equals 0. And now I'm simply going to sketch this out. Vertical asymptote where my 0 should be, and horizontal asymptote at y equals to 0. And now if I want to tell where my function is going to be, I know that if I look on the left side of this, the function is below the x-axis. So on the left side of this asymptote, it's also going to be below the x-axis. The reciprocal is on the same side as the original function. And if this point is -5, the reciprocal is -1/5. You just flip it, and then my reciprocal function is just going to look like that on the left side. I go to the right side, I can see that my function is above the asymptote on the right side, so it's also going to be above the asymptote on the right side. Simply speaking, that's how you do it for a linear function. Let's do one more linear function really quick. I'll do this one a little quicker. Let's say f equals to -2x plus 7. So should be able to do this really quick. X-intercept is just -7 over -2, which is +7/2. My y-intercept is +7. I'm going to sketch it out really quick. (7/2), +7. Oops, it's +7. That's 7/2, and negative slope over there, so line's going downwards. If I do the reciprocal function, again, I've got the asymptote at x equals 7/2. Horizontal asymptote y equals to 0. If I look at the left side of this, it's above the graph, and my intercept is 7. So over here, it's going to be above the graph, and my intercept is going to be 1/7. On the right side, it's below. So it's also going to be below over here. It's going to be like that. Okay, linear functions should be pretty simple. With quadratics, it does get slightly more difficult, but I'm going to explain them as well. In quadratics, we're going to have a couple of different examples though. The first type of quadratic equation you can get is, let's say, something like x squared plus 8x plus 12. Okay, so if I have a quadratic equation like this, I need to first sketch out this equation. Again, you should know this, how to do this in grade 12. So the first thing I'm going to do is factor it with my man method. My m is 12, my a is 8, so my numbers are 6 and 2. So this is going to be x plus 6, x plus 2, and my x-intercepts are going to be -6 and -2. Next thing I'm going to do is find my vertex, which is going to be a minimum in this case because it's a positive equation. I'm going to do -6 plus -2 over 2 for my x value of my vertex. So my x value is going to be -4. And I'll sub this into my original equation to find the y value of my vertex. I get -4 as well for the y value. So now I simply have to sketch this out. -6, -2, -4, 4, positive quadratic equation, so it opens up. And if you wanted to find the y-intercept, you could look at the standard form. It's 12, so it's not really going to fit inside this graph. It's a bit too high, so I'm not going to put the y-intercept on this one. You can always look at standard form and the constant at the end for your y-intercept. Okay, now let me draw the reciprocal of this function. So when I'm drawing the reciprocal, I know I have asymptotes at my zeros. My horizontal asymptote is just going to be y equals to 0, and my vertical asymptotes are x equals -2 and x equals -6. Now, if I look at the left side of this 0, it's above the graph. So on the left side of this asymptote, it should be above the graph. I don't have enough space. It doesn't fit there completely, but you can tell what the shape is. On the right side of this 0, it's above the graph again. So on the right side here, it is going to be above as well. And in between these two, it's below. So I should be below as well. But if I want to find my vertex over here of this function, my x value of my vertex is going to be exactly the same. So -4. But the y value, I'm going to do the reciprocal. It's going to be -1/4. That point is -4, -1/4, and then it's just going to look like that. That's how you do the reciprocal for a quadratic function. Now, not all quadratic functions are the same. Most of them you just have to factor or use quadratic formula, find your x-intercepts, and then do the procedure based on that. But sometimes you're not going to be able to find your x-intercepts, or maybe you're given another form. So I'll show you a couple of different types of questions where you can have a different solution. So let's try this example where I have f of x equals to x squared plus 5. So typically you'll have an x squared term, you might have an a value, and then you'll have a constant being added. And this is if it's a positive equation. Now, if you look at this equation, you should be able to tell pretty simply that it's just a quadratic equation that's shifted up by 5 units. It's positive, so it's opening up. And as you can tell here, there's a y-intercept, but there are no x-intercepts. So you cannot factor this. If you tried quadratic formula, you would get no solution, and there will be no vertical asymptotes in the reciprocal function. So how do I do the reciprocal in this case? Well, pretty simple. I know that my horizontal asymptote is just going to be y equals to 0. There's no change over here. And now this entire graph is above the axis, which means my reciprocal, the entire graph is also going to be above the axis. Let me find the reciprocal of this point here. So 1 over 5, I'm going to extend this out, but this is 1 over 5. So this is a very stretched out graph. Everything is really, really small. And then the reciprocal of this is just a really, really flat line, passes through this point and comes back down, and it's really flat again. So this is what happens when you have no vertical asymptotes. Okay, so simply speaking, this pretty much covers all your cases of quadratics as well, but sometimes you may get questions like this. I'll show you two different questions which are similar but not exactly the same. The first one is, let's say I have y equals 3x minus 4 squared. So if I look at this, this is in factored and in vertex form. Basically, we know that the vertex is going to be the same as the x-intercept, and it's going to be at 4 and 0, and it's going to open upwards. So when I do the reciprocal of this function, again, I could expand that out to find my y-intercept, but it doesn't look like it's going to fit in this diagram. And you can kind of tell because -4 times -4 is positive 16. 16 times 3, my y-intercept is going to be 48. So I'm not even going to fit it in this diagram. I'm not going to bother expanding that out. If I do my reciprocal, again, should be pretty straightforward. My vertical asymptote is at x equals to 4. Horizontal asymptote always at y equals to 0. On the left side, I'm above the graph. And on the right side, I'm also above the graph. So both sides will be above in this case. And for negative functions, both sides would be below when you're in this case as well. So that's kind of shows all of the possibilities. This is going to be 1 over my y-intercept, so 1 over 48. Again, you could just expand that out, get the y-intercept, and do 1 divided by that. I didn't show all the steps in this problem, but I will show them in the next one. The final possibility for a question, again, the steps are pretty much the same, is that you can get a quadratic equation in vertex form only. So let's say I have y equals to x plus 3 square minus 2. This equation is in vertex form, and you don't even know whether it's going to have any x-intercepts or not just yet. So what you can do is you can expand this out. That's x plus 3 times x plus 3. And I'm going to FOIL out these two brackets. So that's x squared plus 6x plus 9. I also combine like terms in the same step. And then x squared plus 6x plus 7. Now I want to factor this. If I try my man method, there's no numbers that multiply to 7 and add to positive 6. So I instead have to do my quadratic formula over here to find my x-intercepts. So x equals -6 plus or minus root of 6 squared minus 4 times 1 times 7, 4 times 8 times c, divided by 2 times 1. -6 plus or minus and then if I calculate this, it's going to give me some decimal value. My first solution is -1.6, and my second solution is -4.4. So now it's pretty much the same procedure. I have my x-intercepts, I have my vertex, and I can just draw this out. So my x-intercepts are negative 4.4 and negative 1.6. My vertex, you can tell that from here, is just negative 3, negative 2. Now I can draw my reciprocal. Should be pretty easy at this point. My asymptotes are going to be at negative 1.6 and negative 4.4. And on the left side, again, I'm on the top. If I do the reciprocal of this point here, it's going to be negative 3 comma negative 1 over 2. And then on the right side, it's above, so it's also going to be above. That's pretty much an entire overview of 5.1.